Hello to anyone who cares to watch these videos. Right now I'm going to explain Arraylist and LinkedList. Alrighty, an array list pretty much is just an array that will get bigger. Now, how you would actually code an array list if you were going to actually program it from scratch, you pretty much make an array list. You make an array, you define it, and then once the array gets filled up, you would make another array, copy the information to it, and make the new array a little bit bigger. And you just keep doing that. And then you would delete the old array and just keep adding all your old data to the new, and then you add more to the new array, and then repeat. So essentially, that's what an array list. Right now, we're going to do this within Java, the built-in one. So you don't have to code it from scratch, at least in Java and certain computer programming languages. So C++, you would have something called a vector, and there could be slight differences in that. I will be looking that up on the video to see, but it depends on the programming language, because programming languages are different, and usually the multiple differences between these data structures would be how they're implemented. A linked list, on the other hand, pretty much it's pretty much just a list of pointers within your memory, and you're linking data together. So linked list would usually have a node. That node could be maybe the root node, the head node, and then you would it would have a pointer to the next node, and then they'd just be like a chain of nodes pointing to each other. So you can have, from what I understand, there are like two types of linked lists. There's one that looks similar to an array, except this linked list will just keep growing, unlike the array. And then you could have a circular linked list where the last node, instead of it pointing to null, it actually points back to the root, and then it would just loop like a circle. So you could pretty much just loop it. It'd be infinite if you wanted it to be. And also with linked lists, which makes it a little bit more, I guess it takes more space up, because with linked lists, if you wanted to add to this list, especially if it's circular, you'd have to disconnect one of the chains towards the end, make it point to null, and then you would have to add another one, add another node, and then connect it to the new node, and then you have to connect the new node to the root node. Or with regular linked lists, if you're in the middle of it, you'd have to disconnect the far left on the chain and connect it to the new node. And then on the right, you have to connect, the new node needs to connect to the data on the right that you disconnected the original one on the left, and you would pretty much create a linked list that way. There are ways to manually make the linked list. In Java, you can do this too, even though there's no pointers. In Java, technically, when you create new objects, you would do it that way. So I guess I'm not going to explain that right now, but I could probably explain it better in C++, but like I said, not sure because it disconnected again. But anyway, if you were going to connect it using the nodes, you're going to connect it, you would pretty much just make an object point to another object. In Java, it kind of does that behind the scenes, because in Java it has a garbage collector, unlike C++. In C++, you have to actually delete the objects manually. So that'd be the main difference. So anyway, without further ado, let's see how you can make this array list. Oh, I did actually do this earlier, so here we go. Array list. Let's see. Array list. I love this stuff. Oh, spelling. Always make sure your spelling's on point. If you don't do that, you'll always run into problems. So, put my name in there. The thing though, in Java, let's see, I'm gonna test it live, but in Java, The built-in one, you can, it has the data set for string integer. It has multiple datas, but if you're coding this from scratch, you would have to actually implement each type that you wanted to put in your data. So just to keep things simple, I'm going to do the string. So there we go. So now on the list I have Ryan, Chris, Mike. Now, there's many ways to do that. Let's do this iterator thing. That'd be awesome. Actually, I'm not sure if iterators will work with this. Iterator list. I know it worked with the other ones. With the actually no, it did work when I did this earlier. Let's see. Could be a reason why I don't though now. Iterator. Oh, well, there we go. That's what I thought. So now I added this. There we go. Right, that's what I thought. So, while loop. There's a way to fix all this blinking on this thing, but I gotta do that with this. Here we go. System. Here we go. And this will print the value. So here we go. While loop. This is what I'm doing. So I define the array list object. In Java, it defines in the background. So yes, I know in older versions of Java, you'd have to do something like this. And you see that's legit though even, but right now I'm using OpenGDK. Okay, maybe that's not necessary. I'm using OpenGDK. If I do this, then I cannot add, because I'm specifically saying I want a string. This shouldn't work if I do that. Exactly, because I'm specifically saying. But without that string, behind the scenes, it has like a data type thing that it's, what's it called? It has a way to shift through data to add into the list depending on the scenario. But if you do this, then it's more versatile. So anyway, I added 3 objects to it, strings in this case. I'm defining iterator because I want to iterate through it. So I'm iterating now using this iterator object. And to make the iterator, you have to define what you're iterating through. So in this case, we're doing the list array, and we have to define it with this iterator. So now you see iterator has next. While there's another object within this iterator, it should print what's in the iterator, which will print through all of our array list. Let's test this out. And underneath here, it says Ryan, Chris, and Mike, as I expected. Also, what I like about the Eclipse, so you do lists, if Eclipse will show you. So you can add things in it. Ooh, you can even add a whole collection. There's all types of things. You can say, you can check for if it contains a specific object, and it's a Boolean here. And it shows you. And that's the beauty of using Eclipse or most IDEs that are sophisticated like that. Anyway, you could also, if you wanted to print a specific object within it, actually, I'm not sure if you could, oh yeah, you should be able to do that with the list. There you go. And just like array, if I say get 0, it should print the first value. So Ryan should appear twice, my name, and it does on the bottom after it gets done iterating through. So you can do that. You could even clear. This should delete everything in the list. Now I probably should get an error if I decide to do that. say LinkedList. Alrighty. Like I was saying, let's see. Do this in a better way. So here we go, list. That's not exactly what I'm looking for. There we go. Let's see what this does. I believe this will show me how many objects are in here. That's what I believe. Should be 0 after the clearing, and it is. And now I'm going to test that because after I added it, it should be 3. So let's test that. Yep, 3. And this is the 3 objects in here. Then after I cleared it with this method, the built-in 0. And if you want to learn more about that, I recommend going to Java Docs, Java documentation, up-to-date documentation for whatever you're looking for concerning Java. That's the point. But enough of the Java thing there. I'm going to show you the linked list, the built-in linked list. So I'm going to comment all this out. Commented too much now. There we go, comment it out. Alrighty, so linked list time. I guess I'll do numbers at the linked list. Linked list. Actually curious. Ah, cool. Linked list is just as easy. This time, do these classic numbers that I like to do. So they're num.add 50, num.add, I mean add 50 twice, 30, 20, num.add 10. All right, and it's pretty similar. Let's try something else, see if I can remember this. I know there's something called a for each loop. Actually, this would be a good time to look up Java Docs, see if I can find it there. Because we can do the same thing we did with an iterator. This is true. You could even use that get method, and you could use that get method to pretty sure it'd be the same if I did here. You could use that get method to use a regular loop, like I showed in previous examples. You could do that. So I'm gonna bookmark this. So you can use I guess, yeah, like you could say num.get, and you could put that in a regular loop, and you could use like put it a for loop and use I and loop through it if you want to. But the problem with doing something like that is you can always loop too much and then hit a num value or a null value. That's why it's not preferred to do that. So here we go. You can go to language, libraries, Java specific. I guess you can go to a tutorial. Really, all I'm looking for is the for each loop. So I'm looking for. I would prefer to find it on Java Docs. Hey, we'd used that before. We use it. So here's a for each loop right here. So it says, looks like that'd be like class. I can read this. Okay, let's see if I can implement it based off reading that for each loop. I could be wrong though, but I am going to experiment. This, huh? I don't think that's right. What I'm trying to do is loop it for each object. That's not right unless, oh, that's C++. No. Let's read this. Forms a given object interval can be processed or action except the action can be for an order of iteration. Exception. Huh. Interesting. For each element. Oh, yeah, because I don't want to redefine it. That's essentially what that is. So nah, that wasn't exactly it. Link all references local and rename does not change the reference of the object. It's been a while since I've used a for each loop though. I'm gonna try this. Let's try to use iterator with it. Equals r dot. No. Oh, it's not what I meant. That's what I'm thinking it might want me to do. Since I'm, yeah. So go ITR and num or something like this is what I'm thinking. That's what it looks like to me. Gonna find out. Alright, it just doesn't want me to redefine it. But that's an interesting thing to me. Huh. Oh. I knew that couldn't be it. It wouldn't make any sense. For each looks interesting. Well, guys, I looked through many books that I've had. I don't know why this for each loop is so mystical and why it's something that shouldn't be in every basic Java book, considering how useful for each loop actually is. So for this, I'm going to give credit to the Java docs because I know how to do all the other loops, but apparently, you know, I don't use the for each loop that often. But keep in mind, like if you want to build like an Android app or something, this loop can be incredibly useful. But also keep in mind when it comes to Android, though, things are like underneath the hood. A lot of things are built under a stack. And once again, though, you don't work with pointers directly, but you do kind of want to keep track of instances of those stacks. Because if you don't, the Java collection, the garbage collection will have, you know, you might crash your app. Even though the garbage collection does do its job, it is possible in theory to overload that garbage collection in theory. So keep in mind that, for example, if one day you want to do like an Android app, it would be really smart to save instances of any I call it, I'm calling them stacks, but that's kind of how the the documentation explains it on a website. But anyway, back to our main subject. For each loop. So I was close in my thinking that I would need an iterator. So I'll give credit to that. So see, it says iterator. And then you have to do the as it's doing. Let's read this. It's some interesting stuff. For each loop, I'm bookmarking this because apparently, even in some of my computer science 1 books, it's mysterious, can't find it. Kind of interesting. So anyway, I'm going to see if I can implement my own. Well, I didn't mean that. There we go. Hate that autocorrection thing. There we go. So I already defined it within here like that. So if I'm going to make it look like this, let's say, I don't know. I don't really see this as a traditional for each loop though. Like, this is not how I see it. Well, I recall when I first learned about iterators. Not iterators, but wow. I recall when I first learned about it is like that in the thing. I have to give credit to the Java doc, the website. Remember, if you're, especially in school, if you do anything like you see a code, you have to give credit to the freaking code, like where you actually have gotten the code from. Or else it'd be considered plagiarism. So that's what he did. So that's what we're gonna do that. But remember, if you do borrow code, not only must you give credit and where you got it, which I am going to do, but you also have to look up the license of the code. That's something I'll have to do though. Look at the license of the code. But I'm not monetizing this video anyway, but you do have to do that. So I don't recall this being the exact way to do it for each loop though. I really don't recall doing it this way. But this is apparently is a way according to the Java docs. So I do new. That's interesting. Yeah, I mean, if I'm going to do this, I might as well just do it through a regular loop, though. But like I said, doing it that way, it's not the best way to do it. Because you're putting yourself at risk of going over the array. First, this is a linked list. I recall doing something like this. If you do this, I think this also clears the array, if I'm not mistaken. Well, we're going to find out what happens. Yeah, well, that did it. It's not the way that I normally would code my code, though. Like, and I guess that also explains why I don't just know how to really work for each loop, unless you actually do it a whole lot. There are other loops I do, but for each is very useful though. you have a bunch of objects, you need to print out all the objects. You could do that without risking crashing your program. And that's the whole point of using loops like this, because if you use it by defining the integer, let's say you don't know exactly how much data is in the linked list. You may not always know that, and that's why doing something like this is a very useful skill to have. That's why it's important, because otherwise you could crash your program, and those type of bugs are pretty annoying. So between linked list, array, and apparently iterators, which I didn't think I was going to go over, but yeah. Actually, I could purposely write it like that, but I'm not going to do that. So that's one useful way to do it. I probably should go over classes, like what I was saying I wanted to do. So it's kind of annoying to do it now because it's blinking up a storm. Unfortunately, there is a solution for it. Just gotta look up how to do that again, because this is extremely annoying. It's probably a Linux problem primarily. Let's do a class thing. I'm gonna delete all this. That's essentially that. Go over methods thing. We already went over a lot of stuff with it, so there's not a whole lot to really go with it, except for public and private, because we need to get into object orientation. Now, if I make a private method, and for the most part, we don't usually make private methods, but if you declare a method private, anything private can only be called by the class that it's declared in. So let's say you have a class that's inherited this class. They will not be able to use this. But this should. But remember, we're not putting static here. We could, but if we do static, remember, it's no longer an instance of the class if we do a static. So I'm curious if this is, yeah. It is no longer an instance of the class. We're going object orientation. So here, should be able to call this method, but not like this, of course, because remember, it's an instance of this class. So there it is, because it's private and it belongs to this class. We'll print out I'm a private method. So now let's add another class. We'll call it, I don't know, door. It doesn't have to make sense for this. This is going to be a class, door. Door extends the wall. So now wall is a parent class, door. I know it would make more sense if I would have called it house. So yes, if you're doing object orientation stuff, it's smarter. Name your classes for a reason. Don't give it silly names like I'm doing this just for example purposes. Because it could have been animal and door could have been, I don't know, bird, for example. So now in door, this is a class. So say void public void, I'm going to say method, and this method, maybe I don't want to call it method. I'll call it something else. I'll call it greeting. Now we got greeting, and do the classic hello world. Hello world. All right. So let's say if I want to, it's inherited from this class. So I probably should have put public and door instead. That would have made more sense. Here, let's get rid of this. Let's take this method, this private method, and let's move it here instead. And let's just swap it. Let's swap. And we'll make door the head class instead. So now it will extend door. Here we go. Greeting, obviously it'll print hello world. So I got that. It doesn't even show up on here. Method. We don't want it to. And you shouldn't be able, obviously this won't work. Why? Simply because it's not visible. That's why, because door is private and only door can use it. But if you were to make this public, like we normally do, now Wall should be able to. See, now I can use it. So I got hello world. Of course, it's not really a private method, but you can now use it because public and door extends. I mean, wall extends from door, and door is like the parent class. So yes, those are cool things you can do with that. See, because it's inherited. So though I made an object of this wall is now extends from door, so it can use all doors public stuff. But object orientation, normally what we would do, well, we would make private variables like A, B, C, integer A, B, C. Let's say we want to do the hypotenuse method again. We're going to return the hypotenuse. Let's call it hypotenuse. So it's going to return C. Let's go pure object orientation here. So what this does is, we know we're going to do this again. C equals square this A, square this B. And I remember I needed like the square root function. I thought that was a real class. Let's do this. Hope we get it. I know I did that in a previous example. Can I remember that off the top of my head? There we go. We shouldn't be returning that because remember that it doesn't do integers with that. We'll make it, we'll see. See about float, see if I can use a float. No. I bet, yeah, I probably could, but I would have to do this. Yeah. So we're gonna go pure object orientation. So we're gonna make a setter. I wonder if scanner is included in that. Scanner, scanner. There you go. Here I just define a way so the user can get input. So this could be called input, for example. It gets data from the keyboard. Value of A. So next, and we don't, well, yeah, we have to do this, but we gotta freaking convert this value. So I think it'd be better if I redefine this all as float. So I could say next float. Here we go. So I'm wondering if I even need to do that since it's a setter. This should set the value of this A. I gotta do something similar for B. Or we could say set cosine. Essentially, that's what that is. Cosine, sine. Cosine. This actually returns the value. Yeah, but it returns the value, so I know why I'm going to do that. You call it. I'm going to use camel case for this. There we go. Now, do this. Did I? Oh, here it is. So now I'm going to go set cosine, set sine. Maybe I spell that, of course. Yeah. This actually returns a value, and I have no parameters this time. There we go. And now I'll pull out my handy calculator. Let's see, we'll test it. Let's go test it. It says input cosine. So I'm going to input 4. I'm going to input for sine. I guess I'll just put 2. And it gives me the value. And I'm going to see if that's right because I think it's pretty cool. I got 20. And then I got to do the whole root of the 20. Yeah, that's about right. And round it off with the float. Round it a little bit. Yeah, cool. Yep, that's right. So yeah, you can do cool stuff like this with object orientation. And this is essentially how it works. This is a private, and you access your private variables through your public functions or methods. And then you can have a main class that inherits. I mean, you'll have a child class that inherits from the main class. In this case, it'd be door. And I can access all the public methods, the public ones, through the object. And I can access that through by using the methods through here through the door, and then I can use the private methods, the private the private variables by using the public methods. You can also, which I will go over later, we'll go over virtual class, and we are going to do templates. And after I do that, I'll move on to doing some C tutorials, or maybe I'll try to build something really cool using Java and just document it. That'd be really cool. But I'm thinking if I'm going to build something with Java, I'll probably try to build another Android app, something that's kind of cool and useful. Because I do have Android Studio on my computer. But yeah, I mean, we could do that, or maybe I can do my other projects. But if I'm going to continue with Java from this point on, after I do the main things, then I'll be building projects with it. And there's really not much else to go over when it comes to programming. There's just minor nuances when it comes to like syntax, stuff like that. Just minor nuances about it. That's just something also. I want to give credit for that. For each loop, the docsoracle.com, Java 8 right here, like giving full credit for finding out how to do that on this website. I claim no credit towards any of the code that comes from the for each loop. And I do know there's a more smarter, better way to do the for each loop because I've actually done it before. It's just been a while since I've played with the for each loop. Anyways, if you like the video, like I say, do what you want. You could subscribe, not subscribe, like or comment, or even better if you just give me some advice about anything that I might be missing, or if I got something wrong. I'm open for correction, because correction, that's how we become a better software developer. If you just think you know everything, then you won't learn anything new. And in the industry of software development, we always have to be trying to learn new things, and we can't get stuck in old ways or else we become obsolete. Thank you for your time. And until next time, peace.